Hello. In the LINQ demos I did previously, all the queries were done on objects in memory on lists that I had built by hand. And that's not a very real world situation. What is much more likely to happen is that somebody gives you a big file with data in it, either somebody from another department or somebody from another business, and they're like, here's all the account data, you go do what you need to do with it. And here's all the invoices, you just go process them. So we're going to look at a scenario like that. Now, one of the most common ways for information to be exchanged is using XML. XML and JSON are two very commonly used, it's like transport mechanisms or sort of formats, user-friendly, human-readable formats for exchanging information. XML is a little bit easier to read. I like it better. And they're both used all the time. Anytime you make a little request from an app on your phone and it goes and gets some data, it's either going up and coming down or it's probably coming down to the phone as either XML or JSON, and then the app on your phone is handling that information, parsing it, and doing something with it. So this is a sample of an XML file. XML is very much like HTML, which we kind of learned about very, very briefly with the bingo card activity. It is a tag-based format, except that rather than having built-in tags, you can define the tags yourself. And the tags can have names that are applicable to your particular context. Actually, if I pop open this right here, this is a very, very small XML file. And I think you'll understand it pretty quickly when you look at it. So it has a start tag that says, here's the beginning of the XML. Here's the end of the XML. And inside of those tags, I have weather information. And inside of my weather information, I have an entry for a city. So the XML contains weather, and the weather contains cities. It could contain one city, it could contain multiple cities. And notice that this city has attributes. It has a name, a pressure, a temperature, and a sky coverage. So this is a sample, a very simple XML file. And the fact that it is in plain text and the tags have meaningful names like weather and city instead of H3 makes it XML pretty easy to work with. I mean, you can open up a file and kind of figure out what's in there. Here's an example of the type of XML file that we're actually going to process in this activity. It's just, this is a complete file. What I just showed you was just the first line of the file. But you can see that our weather information contains numerous cities, and each city has its attributes. So what we're going to do in this activity is read in a document that's in this format, and then we'll be able to apply or perform LINQ queries on that data to say, okay, find me the hottest cities, find me the coldest cities, find me the cities with the lowest barometer and the highest barometer, find me the weather for Columbus, Ohio. So that's what we're going to do. We're going to load all of this into our project and parse it and do stuff with it. And I think you'll find that this is surprisingly easy. Now, C# has excellent capabilities for working with XML files. And one of the things that it has is an XML deserializer, which means that if you give it an XML file, it can load that into a class structure that wraps that data. So it could create an XML object, which would contain a weather object, which would contain a city. And each city would have a name, pressure, temperature, and sky properties. It can do all of that for us. The trick is we just need to put some information called annotations into the XML file to tell the deserializer what it's actually looking at. It's saying, okay, here's an entity, here's an attribute. Now, I'm going to just fess up that I don't even know how to write that, because there's a website that you can just drop your XML file into that will generate all of that stuff automatically, and then you can just copy it into your program. So you can go on a fishing expedition learning about all the possible tags, trying to do it by hand and making all sorts of errors, or you can just take your file and drop it into this website and have it generate all the information that you need, and that's what we're going to do. Now, if you're doing this yourself, for a business purpose or some other purpose, it is important that the XML file that you use to create the class map or the class hierarchy that represents the data has to be complete. So if you give it an XML, let's say we gave it this XML file, and it generated a class hierarchy for us. But then a few weeks later, we added a new field to this. Well, the class hierarchy wouldn't know about that field. So the data that you use to generate the class wrappers should be a complete representation and contain all the possible fields that the deserializer will need to know about. So let's take a look at putting this file into the deserializer, and we'll see what we'll put it into this website and turn it into a class hierarchy that the deserializer can use, and then we'll see what that looks like. So here is the website you want: xml to c#.azurewebsites.net. This can do for us instantly what it would take a long time to do by hand in a slow, tedious, error-prone method. All we need to do is just take our file and paste it in here and click convert, and this website will generate a class hierarchy that mimics the structure in the XML file. So let's go grab our XML file. Now, it doesn't have to be the complete data. I mean, we can take all this and drop it in there, or we can just drop in a subset of the data as long as it has all of the tags that you'd find in the complete document. But I'll just take the whole thing here, and I'm going to go to that website, and I'm going to paste in my XML file. So this will generate for us a class called, it'll generate for us a class called XML, which contains a class called Weather, and it will see that there are many cities inside of Weather, so Weather will get turned into a list. It'll be turned into a list of cities. So let's go take a look at let's run the convert button here and see what it generates for us. So here's what it generated. You can see it generated a class called city. Well, it put everything into a namespace, so we're going to have to deal with the namespace issue later. It created a class called city, and it turned every one of the attributes in that XML file into a public property. And then it annotated the public property with the information that the XML deserializer, which is the class that reads the XML file, will need. So it just puts this element tag in front of anything that's a class, and anything that's a member of the class gets the attribute tag. So it's really not that complicated, but if you were doing it by hand, it would be slow and tedious. So there's a class that represents each one of the cities, and then it created a class called Weather, and you can see that Weather contains a list of cities, and then the XML class contains a class called Weather. So XML contains Weather, Weather contains the list of cities, and each city has these public properties. Now, one thing to notice here is that if we actually went back to the data, we'd see that pressure is a floating point number, and so is temperature, and sky is an integer. However, this website does not know or cannot really infer the data types from the document. So we will probably want to leave name as a string here, but later we will want to convert. We'll just change this. We'll just say, okay, instead of a string, we'll make it a float, and we'll make that an int. And then also, we probably don't want to leave this as city in the singular. We can change it to be cities plural, so it just makes more sense. We can say weather.cities and do our LINQ query on that. So what this is going to do is allow our program to take this and load it into a class hierarchy of this. And once our data has been loaded into these objects, then we can perform the LINQ queries on them. Now let's pop over to Visual Studio and look at what the application is going to look like. I am going to pop over to Visual Studio here, and this is what our interface is going to look like. This is just a text box. This is a text box with the multi-line property set to true. These are all list boxes, which means that they have an array of items that we will be able to put data into, or strings into, or whatever. The objects, the results of our LINQ queries. So what we're going to do is like display like the 5 hottest cities, the 5 coldest cities, the 5 cities with the lowest barometric pressure, and the 5 cities or 10 cities with the whatever we want with the highest barometric pressure. And this will be used for looking up a city by name. So we'll be able to type in something like Columbus, Ohio, or New Haven, Connecticut, and click search. And then if that is found, it will show up here down in the current conditions. Now, I'm just not going to walk through actually building the interface because I think you can probably figure it out at this point. We've built enough interfaces. Now let's get this stuff into our project. And notice here we've got these using statements that bring in the XML library. So in our main, our Form 1 class, we are probably going to have to use system.xml.serialization. So we'll have to copy that into Form 1 at some point. So what I'm going to do here is just go into the website, and I'm going to do a Control-A and Control-C, and I'm just going to copy that text. And now I'm going to go to my project here, and I'm going to add a new class. And I'm going to just dump that information in there. So let me right-click on my project, and I'm going to say Add. I'm going to add a new class. And let me call the thing like class, XML class mappings or something, or XML mappings, I don't know. Call it whatever you want. And you can see it has created a new file for us. Our namespace is XML demo, and we're going to need to know that here in a second. Now what I'm going to do is I'm just going to delete everything out of here, and I'm going to paste in the code from the website. Now you can see the problem here is that our namespace is not the same as our other projects. So I'm going to change the namespace so that they match. Otherwise, I'd have to do like an import Azure websites or whatever that thing was. I'd have to do an import statement, and it's just going to be ugly. So if I just make the namespaces match, then my life will be much, much easier. And now let's go through this class here, these classes, and just change the data types for these properties. So name, we'll just leave that as a string, but the pressure, let's change that to a float. And the temperature, let's change that to a float. And the string, we'll change that. Or, I'm sorry, the sky coverage, that's the percent of cloudiness. What percentage of the sky is covered? That is an integer. So we have string, float, float, int. And then in our weather class here, let's just to make this a little more human readable, I'm going to change city to cities, just because if it's plural, then we'll kind of understand that cities is a list of type city. And then finally, our top level document is called XML, and we'll just leave it like that. Do we really need this top level class called XML? Not really, no. If we had chopped off, if we just had an XML file that said weather or cities and then closed with the weather tag down at the bottom, if we just removed that outer tag, then we wouldn't have to have the XML layer. It's kind of a useless layer that does nothing. But just XML documents are usually enclosed in XML tags, which is why I made it that way. And that's all we need to do. So now we're here back in our XML mappings. So this class structure matches exactly the data hierarchy found in our XML file. And now that we have this format, if we just can look up 3 lines of code, we can actually load any XML file in this format into an object and then perform LINQ queries on it. So let's go back to our Form 1 class now. And what are we going to do here? I'm going to go all the way up to the top here. And what do I need to do? Let me add using system.xml.serialization. And I think that maybe we have to add system.xml too. System.xml. We'll just put them both in there just to be safe. And now we'll have access to the classes that we will need to deserialize our data. So what are we going to deserialize our data into? Like, we're going to open up an XML file and load it into a class hierarchy that's going to be created for us. That's this thing down here. That's our. This is kind of the object that's going to be the root of our class hierarchy. The XML contains the weather, which contains the cities, which contains all the data for each city. So back here in our form, we can actually make an object of type. Was it XML? Why not? Oh, you know why? Why? You tell me why. Notice that my namespace is XML demo spelled like that, and I misspelled my namespace back in the class mapping. So if I come here, you see I just spelled it differently. There you go. Just the namespaces have to match, otherwise you won't be able, the IntelliSense won't be able to find the matching file. So now what I can do is I can actually make an object of type XML, and I'll just call it XML data. And let me allocate it just to be safe. New XML. Can I do that? Equals new XML. All right. Sounds good. So now let's add an XML serializer. So this XML serializer can take XML data and load it into a hierarchy if you give it the type information about the hierarchy. So if you give it a class, it can say, all right, I know how to now load XML data into one of these hierarchies. So let's make an XML serializer, and I'm just going to call it SER for serializer for short, equals new XML serializer. And let's look at the constructor here. It takes a type. It takes the type of an object. Well, how do we get an object's type? And what type of object do we use? Well, we're going to use our XML object that we just declared. And we can say type of, there we go. So it's like a macro, or I don't know what it is actually. XML. So this XML serializer can read in files whose data is described in one of just described by this object, and it's the class hierarchy that it's the root of. So this thing, our XML deserializer, is going to read in a file and populate this thing. So let me just mark that here. Our data hierarchy, right, which is basically a big tree of data, and populates or reads data into the tree. So that's what those are. That's what that's going to do. Now, let's go add. Let's back here on my file menu. I'm gonna I'm going to add this menu option here, and what I'm going to do is allow the user to pick a file. And actually, if I'm going to be working with files, that probably means that I need system.io. So let me go back here. Do I have system.io? No, that's like the one library I always need, and it's just not included by default. Although I bet I could probably find a way to make a template for it. So let's add system.io, and then we'll be able to do file stuff. So let me go to my interface here, and then I'm going to double click on Open File. So here's where I'm going to ask the user to pick a file, and then if they pick a file, then I'm going to load the data from that file into this using this. So how do I pop up a file dialog? Well, that's our Open File Dialog class, and I'm going to make one called OFD equals new Open File Dialog. And then let's put a filter on this thing so it just filters XML files. So it doesn't, you can't accidentally open a binary file or a JPEG or something like that. So the Open File Dialog and the excuse me, the Open File Dialog has a filter property on it, and we can set that to. So the format for that is that you have kind of the on either side of a pipe you have like the type of the file, the name, like the kind of the Englishy name, and then on the other side of the pipe is the extension. So on the left side we'll say, XML files, and then star.xml. So what this is like the human readable, this would be like image files, and then over here it'd be like .jpeg. So that's the relationship. This is like, all image files, and this is the specific type. So now we'll only be able, the Open File Dialog will just show us the XML files. And then we just pop it open using its show dialog function. And the show dialog function will pop this thing up and wait for the user to press a button and return us the code of the button that was pressed as a dialog result object. So if I just pop the thing open, Open File Dialog dot show dialog, there we go, equals. Now what if you were like, okay, well where did he get that stuff about the dialog result? If you just hover over show dialog, it shows you here in the IntelliSense that it returns a dialog result. So we'll check what the code of the button was on this, and it should be ID, or just, sorry, okay. So we pop this thing open, and if the user clicks OK, then we'll end up inside of our if statement, and here's where we actually want to do the work of loading our XML file into our class hierarchy. So what we're going to do is open the file as a stream, read everything out of the stream. So how do we open a stream? Well, the thing that turns out we need a stream reader. I'll call it SR. This will read all the data out of a file. And I'll say new stream reader. And I have to give it the name of the file to open. So there's one of the overloads. Is I give it the path of the file to open for reading. And I have the path because it's in the Open File Dialog's file name. File name. There it is. There it is. So open this file name, open a stream for reading the data out of that file. And now we'll deserialize that stream. So where's our, I think our deserializer was called serialize, or ser dot, there it is, deserialize. And you can see it's got a serialize too. So we could actually, if we made changes to this document, we could actually rewrite it back out. But we want the deserialize function. And what does that take as a parameter? It takes the stream. It takes the stream to read from, and I'll just call it stream reader. Now, what is this thing going to return to us? It returns an object. That object is going to be our XML hierarchy. Why? Because up here, when we created it, we said type of XML. So it's going to return us an XML object. And let's, no wait, okay, so what's it going to return to us? What's our data called? What's our thing called? XML data, there it is. That's where we want to store it in our class variable. So we're going to read all of the data out of the file and stuff it into an object whose root is this. Now, you can see that there's a type mismatch here because cannot implicitly convert an object to an XML object here. So what I can do is I can use a C# typecast. That would work as XML. That would work. And that's actually it. So it's just those two lines. You just open up a stream to the file and use the deserializer to read out all the data and store it in your object. And we declared that way up here in the top of the class, so it would be easily accessible. And if you want, if it makes things make more sense, you can take this, and we only need that when we read the file. So you could put it down here too. Create a deserializer that can load data into one of these things, open up the file, read all the data out into our object, which is going to be the root of our tree. And so let's just run that through the debugger and see that it works. So I'm going to put in a breakpoint there, F9, and let me run. I'll put a breakpoint in here too, and let me run this. And now let me go to the File menu, and I'll say Open File. There we are, and now it's going to create an Open File dialog. It'll set its filter. It'll pop it up, and now you can see now it's asking us to open an XML file, and you can see down here it says XML files star.xml. Right, so that's what we're going to see, and now the stuff on the left side of the pipe, that's what we see in the drop-down. And now let me go find my XML file here. And now let's create our deserializer, open up a stream to the file, and then read the stuff out of the file into our hierarchy. Now let's look at this. If I expand this, you'll see our XML data contains weather, our weather contains cities. How many cities? It contains 128 cities. So we have just loaded all the XML data out of that file. And now it's in this object, and now we can perform LINQ queries on it. So let me just write one LINQ query here just to get you going. I think I'll make a function for each one. I'll make a function called like void show hottest, and then right after I read in the data, I will call that function. So after I read in the data, I'll call show hottest. It'll jump down here, and now let me do a LINQ query here. So let me do make a var for my result set equals, and then I need to write a LINQ query, and the format of a LINQ query is, the from clause comes first. So I'll say from C in, and what am I selecting from? Well, from my XML data, and my XML data contains the weather, which contains the cities, right? So this is a list. Cities is a list that contains 128 cities. And let's see, if I want to sort them by temperature, that's going to be an order by. Order by is one word in LINQ. Order by C dot temperature. And if I want the hottest ones, I want to sort them descending. And then select C. So I want to select everything out and then order them by temperature descending. Now the thing is, maybe I don't want all of them. I just want like 5. So I'm going to put a wrapper around this that says take 5. So that will sort the cities descending by temperature, and then just take the top 5. Now that I've got the cities here, what I need to do is just dump them into that list box, and I kind of, in retrospect, wish I had used data grids for these, because then I could just dump the objects right in there and they would show up all nice and formatted. But so I'm just going to have to kind of brute force this, and I'm going to use a for each loop to do it. Oh, not a for loop. Let me use a for each loop. For each var, we'll call it C in hottest. And then let's put them in list box 1 here. List box 1 dot items dot add, and then let's make a string here. Or we don't even need a string formatter. We can just say C dot name plus colon plus C dot temperature plus, and I think they're in Celsius, or I forget. Now why does it not like, oh, not add range, add. There we go. So what that's going to do is add that string into the list. So let's run it again and see what it does. And I'll pick my XML file, and it will load the run the file, or load the file. And oh, somehow the debugger didn't stop, but you can see there Gilbert, Scottsdale, Chandler, Mesa, Riverside. Oh, and it looks like they did come out in Fahrenheit, so I must have put Fahrenheit data in the file. Let me run it again. Open the file, pick the file, and well, now it's stopped there. F10. Now remember, there's delayed execution on the query, so hottest has not been populated until I try to access it. So it actually hasn't been populated, and as soon as I run this, now the query gets populated, and now it's going to cycle through there, putting all of the populating the list box. So coldest, lowest, and highest, those are all just variations on show hottest. While we're in here, let's look at the query to select information for a specific city. What I want to do here, well, I'm just going to go into the properties and disable this button. I'll set its enabled property to false. And oh, because I can't do that because I'm debugging. But let me try that again. Set the property to enabled to false, and then this is button 1. After I load the file, I'll set its enabled property to true. So let's go into the code here, and after we load the data, I'll set button 1 enabled property to true. That way I can't click on the button and search, try to do a query on a null object, on an object that hasn't been initialized yet. Now this this button right here, what is this query going to look like? There's a little bit of a gotcha hiding in here, and I'm just going to show it to you, and then that'll get you past it. And the gotcha is that we only want one object back, but we're still going to get a collection of objects back anyway, and it's just that collection is only going to contain one object, or maybe no objects. So that's what we've got to take a look at here. So I'm going to make a collection, or my result set is going to be called cities, and then I'll do a LINQ query on my XML data. And remember, the from clause comes first. From, I'll call it C in, and what am I selecting from? The XML data's weather's cities. And what am I searching on? What am I filtering on? Where the name of the city matches whatever is in that text box. So where a city's name is equal to text box 1's text property. Select C. And now I don't, and I can also just put a dot limit 1 on here. Why is it griping about? Oh, not limit. Sorry, limit is SQL. Take 1. So that'll give me a collection back. However, the collection will contain 0, or it could contain no cities. What if I type in garbage and I don't get a city? And I don't get a city back. I get an empty result set back. How am I going to handle that? Well, cities, which you can see is an IEnumerable of type city. It's something that implements a list-like interface. We can check to see how many things are in there, and we can check its count property. So if cities count property, oh wait, cities count, count. So that should be enough to get you going there. The trick is you just have to make sure that you check how many results you get back, and since you only want one thing out of the result set, you have to grab the first thing out of the list, because even though we're just selecting one city, we're not getting a city back. We're still getting a collection of cities. Well, there you go. I really like this activity. It's very useful. My text adventure engine, all the project files are saved as XML using this exact technology. This is really useful. I mean, I've worked in departments where we exchange XML files around, and it's very useful for you can pull data down from a server if you have the URL, get the XML file, process it, do something to it. So I don't know, really cool little activity, much more useful than just kind of doing LINQ queries on objects that we hand code. I hope you're impressed by this. Certainly you have enough to finish it up. If you need have any questions, just email me. I'll be happy to help you.